Chapter 5.1. Chapter 5.1 deals with the bisector of triangles. In the first theorem, we're given that if we have a segment AB and we find the line that is the perpendicular bisector, in other words, it cuts AB in half, it doesn't matter what point we pick on that perpendicular bisector. If we draw segments from a point we pick on that perpendicular bisector to segment AB, the endpoints, those will be congruent. And it doesn't matter where we pick a point on that. The converse tells us the opposite way, that if we have a segment, call that AB, we cut it with a line that we know is perpendicular. If we pick a point on that line and we draw segments to the endpoints of the segment, and those are congruent, then we know that it is a perpendicular bisector. In problem A, we're told by the diagram that DC is the perpendicular bisector to AB, so therefore AC and BC have to be congruent, so it's 8.5. In the next problem, we're not told that WY actually bisects the segment WZ, but since it is perpendicular to XZ, and that WX is congruent to WZ, we know it does bisect it, so this has to be 6. To find PQ, we would set the two segments equal to each other, solve for X, and then plug the X back in to solve for PQ. We're asked to find the length of NO. It is a perpendicular bisector, so this would be congruent to this, so 9.2. Since WT is congruent to WV and WU is perpendicular to TV, we know that TU has to equal UV. And C, we're going to use algebra again to find X, and then plug back in to find EH. So X is equal to 8. Plugging it back in to find EH, I have 5 times 8 minus 20, which would give us 20. In this chapter, chapter 5, we're going to learn 4 different types of centers. My suggestion would be to create flashcards that has the name of the center, maybe a diagram of the center, and then how we constructed it and the special, whatever's special about that center. So for the circumcenter, we're going to find the perpendicular bisector of each side. So we perpendicular bisect each side, and the intersection point of that perpendicular bisectors of all 3 of them is called the circumcenter, and the circumcenter is equal distance from the vertices, or the angles, whatever you want to call them. So in other words, as P is the circumcenter, then PB is equal to PA is equal to PC. One of the common questions is all the pictures don't look like they're equal. That's because we're testing you on that, or sometimes when something is brought from one textbook to another, it gets stretched in the picture. What we're really testing is your knowledge that these are equal distance from each of the vertexes. So the next problem is saying that if we had a triangular shaped garden, can a fountain be placed at the circumcenter and be still inside the garden? So in other words, is the point of the intersection of the three perpendicular bisectors of the sides, does that intersection point occur in the garden or outside of the garden? In this class, I'm not teaching constructions, but I have posted, just so you can see how this all works out, another video on constructing circumcenters and also constructing incenters. So you can see how they're constructed, see that they are equal distance from the sides or the angles, whichever one we're looking at. So for this, just to talk about it, I'm going to eyeball it and just sketch it. So if I look at XZ, right there would be about the perpendicular bisector. If I look at ZY, about there would be the perpendicular bisector, or a little off. Right there. As you can see, it's going to intersect on the outside. And I apologize, this is one time that it really did not come out nice when I drew it. So let's look here again, about right there. And go through that point there. And about right there would be the perpendicular bisector. So if the triangle is obtuse, the circumcenter lies outside of the triangle. Because even if I look at the perpendicular bisector for XY, it's going to go through that same spot right there. The next picture shows an acute triangle. It actually looks like it's an equilateral triangle. The construction videos that I posted do not have equilateral triangles, so it really shows you how it all works out. But here again, if I just sketch it, the three perpendicular bisectors would fall inside of an acute triangle. The next two theorems deal with angle bisectors. And what these theorems are telling you that is if you have a ray that bisects an angle, then you know that it is equal distance from the sides. And the shortest distance from a point to a line is perpendicular. The converse tells you that if you know that you have a ray that's inside of an angle and is equal distance from the sides, that it bisects the angle. So we're asked to find the length of DB. We're given that AD is the bisector of angle BAC. So BD is congruent to DC. So that would be 5. Here we're not told that WY is the bisector, the angle bisector, but we're given enough information because we're told that WY is equal distance from the sides of the angle. So this would be 28 degrees. To solve C, since we know it's the angle bisector, we know these are congruent to each other, so we set them equal and solve for X. Then use the X to find QS. So QS would equal 4 times 3 minus 1, which is 11. Here again, we are told that QS is the angle bisector of angle PQR. So we know that PS is congruent to SR. Since FH is equal distance from the sides of angle GFI, we know that it bisects the angle. So this would be 30 degrees. And I know there's two 30s. And this one we're told that UV is the angle bisector, so we know that we're told that TV is the angle bisector, so we know that UV equals VW. Again, we'll solve for X. Use X to find UV. answer would be 19. And here's the second center. This center is formed by the angle bisectors. So we're going to bisect each of the angles. So we're cutting each of the angles in half. Once we find the end center, then that end center is equal distance from the sides. So EP would be congruent to DP, which is congruent to PF. So with a circumcenter, you create it by finding the perpendicular bisectors of the sides, and that intersection point will be equal distance from the vertices or from the angles. With the end center, you find the three angle bisectors. The end center is the intersection point of those, and that intersection point is equal distance from the sides. So on problem A, we're told that ST is the end center of angle MNP, of triangle MNP, which means that we bisected each of the angles to find the end center, and we know it's equal distance from the sides. We're asked to find ST right here, but we know that ST is congruent to SU is congruent to SR. I don't have enough information to find ST, but if I find SU, since it's congruent, I'm okay. So if I let SU equal X, then I have a right triangle. So if I redraw it down here, here's U, S, and then I name that X. SP is 10, and UP is 8. So I have a right triangle and I'm missing a side. To find the missing side, I would use the Pythagorean theorem. So I have x squared plus 8 squared equals 10 squared. Then I have x squared plus 64 equals 100. So x squared equals 36. Now I can solve for x by square rooting both sides, but when I square root both sides, I have to remember that I need to write plus or minus 6. Because when I square root both sides, I have both the positive and the negative answer. If you just put one of them, you're incorrect. I do know that the answer to this is 6. So yes, in the class, I would just take that x equals 6. But when you go on to Algebra 2 or to any other maths above this, if you just write x equals 6, you will be incorrect. In the next problem, we're asked to find the measure of angle SPU. So we're asked to find the measure of this angle right here. To do that, since I know that this angle here is 31, and this angle here is 28, I can work my way around the triangle to find it. So in other words, if I find the measure of angle M and the measure of angle N, then I can find the measure of angle P and divide it in half to find the one I'm looking for, because with an end center, I am looking at the angle bisectors. So the measure of angle M would be 2 times 31, which is 62. The measure of angle N is 2 times 28, which would be 56. To find the measure of angle P, since all the angles in a triangle have to add up to be 180, I could add these two and then subtract it from 180. So it's 180 minus 118, which gives me 52. So the measure of angle SPU would be half of that because we're bisecting angle P, and that would give me 26. Excuse me, would give me 180 minus 118 will give me 62 degrees. which would make my answer, half of that would be 31 degrees. In problem A, I want to find the measure of GF. So GF I'll mark by X. If D is the incenter of triangle ACF. So if D is the incenter and I want to find GF, I have a right triangle, so I can use the Pythagorean theorem, 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. And I get as an answer, when I solve for x, is plus or minus 12. I'm not going to use the negative answer, so the answer is 12. In the next one, I'm asked to find the measure of angle BCD, so this angle right here. I know that each of these angles are bisected, so if I can find the measure of angle A, the measure of angle F, and use those to find the measure of angle C and divide that by 2, I would have my answer. So the measure of angle A would be 2 times 35, which is 70 degrees. The measure of angle F is 2 times 29, which is 58 degrees. I would add those together and subtract from 180. So 180 minus 70 minus 58, which gives me 52 degrees. I would divide that by 2, so the measure of angle BCD is 26 degrees. The rest of the problems on this packet are extra problems to prepare for a quiz or a test. The solutions to those are posted online in these notes that we took in class. Thank you.